we're going to be given a function, and the name of that function is going to be h of x, and we have to rewrite it as a composition of two functions. There's a few major strategies that will help you here, but ultimately we're going to go through a lot of examples because the more of them you see, the easier it is to understand. Okay, so let's start off with this first one here. I have h of x is equal to the quantity 2x plus 7 cubed. One big strategy is whatever is in parentheses, or maybe less specifically in grouping symbols, is usually your input function. Because good notation when you're about to make substitution is to turn the variable into a set of parentheses and then insert something. So in this first one here, really emphasizing the set of parentheses, what's inside those parentheses is your input function. So if it's f comp g, g is the input function. So I'm going to say that g is equal to 2x plus 7. Now just color coding this a little bit of what we have right now, if what's inside parentheses was your input, everything else is your output, or is the function you're plugging it into. So the set of parentheses to the third power, that is x cubed. So let's go backwards for a second. If you were given f and g and asked to find f comp g, you would go into the f function and replace that x with 2x plus 7, and we'd be right back to that. Okay, so again, looking at lots of examples is going to help us kind of wrap our head around this. So one major strategy is wherever the grouping symbols are, what's inside grouping symbols is your input function. So in this one, here's my grouping symbols, my set of parentheses, and what's inside of that is x minus 1. So I'm going to say that my input function g is x minus 1. So then I'm just going to kind of cover that up, the x minus 1. Everything else is what the function was before we inserted x minus 1. So this is going to be x squared plus 4. Okay, now let's go backwards. If I wanted to find f composition g, we would start with the f function, and every place we see an x, we would replace it with the g function. So we would replace that x with x minus 1, and we'd be right back to the original. Okay, so here's another one. This time the grouping symbols is a set of absolute values. So just emphasizing those absolute values as the grouping symbols. What's inside the grouping symbols is my input function. So my input function for this one is g. So the g is x minus 3. And then what we have left over here is my f function. So 4 absolute value of x. Let's go backwards for a second. If this was my f function, and I went in and replaced this x with x minus 3, we'd be back to the original. Okay, so here's another couple problems. These ones, we have a square root. Now a square root is a grouping symbols. So just emphasizing those grouping symbols, what's inside of there is 7 minus 5x. So that's going to be my input function. And then if I just kind of wipe that out, what it was before I inputted 7 minus 5x would have been the square root of x plus 6. Okay, going backwards, if I said find f comp g, you would start with the f function, replace this x with 7 minus 5x, and we would be back to the original. Now, when you have a fraction, maybe you're not sure where the grouping symbols are. Fractions, there's a set of parentheses around the numerator and around the denominator. So there's a little bit more going on in the denominator. So I'm going to put the set of parentheses there. So the input is x minus 5. And then just covering up that x minus 5, the function before I inputted x minus 5 would have been 1 over x plus 2. Going backwards one more time, if I said f composition g, I'd start with the f function. Every place I see an x, I would replace it with x minus 5, and if I do that, I'd be back to the original. Now the first strategy here is look for the grouping symbols, and what's inside grouping symbols is your input function. But sometimes we have functions like this, and if we look for the grouping symbols, what's underneath the root, that's grouped together. But plain x is not enough. The input function can't be plain x. So we're gonna need to just, another strategy is take those set of grouping symbols and just make them encompass a little bit more. So I bumped that out a little bit farther. And so then my input function is going to be the square root of x. And then if I cover up the input function, what it was before we inputted it would have been 7x plus 5. Okay, so going backwards, f composition g would be go to the f function, replace the x with the g function. So if I replace the x with the square root of x, I'm right back to the original. Okay, last example. Same thing kind of happens here is I try to put a set of parentheses, grouping symbols around the x, but plain x is not enough to be an input function, so I just move that out a little bit further to capture a little more. So I'm going to go with x squared. So if x squared is my input function, if I take out the input, I have 4x plus 1. So 4x plus 1. Going backwards, replace the x with x squared, and I'm back to the original. It's good to know that these problems that I'm running through here as examples, they are not unique solutions. If you would have moved this set of parentheses out even further to be, say, 4x squared, I could have let the input function be 4x squared and then that be x plus 1. But the two main strategies, put a set of parentheses inside grouping symbols, or the parentheses are the grouping symbols, that's your input function. And if you can't capture enough, just bump those out a little bit further to capture some more.